Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Konrad.
Welcome to the Reliability Matters podcast. Thanks for being with me today. I'm Mike Konrad, your podcast host, and we are in beautiful sunny San Diego, California for the IPC Apex Expo. My thanks to Trevor Galbraith for letting me interlope into his booth to do this podcast, and our dynamic production team, Summer and David, and a few other people that are making all the, pushing all the buttons at all the right times, making this look as good as it possibly can. So. And thanks to you all for watching or listening. We're live coming from, again, Apex in San Diego, and this will also be available on demand afterwards on the Reliability Matters channel, and so just keep an eye out for that. If you missed the live, there's a second chance, but then again, you already know that if you're watching this. So today, I'm going to bring back probably the person that's been on my podcast more times than anybody else, my friend and colleague Eric Cambden from Foresite. Eric, good to see you, man.
Hey, good to see you as always, Mike. Thanks for having me on the floor.
Well, you're very welcome. I love talking to Eric because Eric is a failure analysis investigator for Foresite. We'll get into what that means in a little bit, but he's like a CSI, like crime scene investigator, only instead of murders and burglaries and extortion and all the other things, the crimes are sins of the electronics process, breaking best practices. And I always like to say that when I produce webinars with multiple speakers, I'll have Eric as the last speaker. And I always say, if you don't listen to the first three speakers, you're going to meet Eric at your facility. Today is free. At your facility, it's not free. Far from it. So I'm really glad that you're with me today. Let's talk about reliability. And in our worlds, we share one common interest, and that is reliability generally has to do more with residue removal and contamination and things like that.
Sure.
That seems to be our field of expertise, although there are a million other things
Absolutely.
that can affect reliability. We play in the cleanliness sandbox, right? So tell me a little bit about Foresite. You're a laboratory. What kind of work do you specialize in, just so that we can put your frame of experience into perspective?
Sure. Foresite's been around a little more than 30 years now as well. It's kind of similar to the timeline that Aqueous technology came out. And at this point, I would say we're a good mix of failure analysis and process qualifications. So, we always say it's cheaper and easier to do it up front, to get all your answers up front than try to chase down a failure with recalls or something like that. So we've become a pretty much 50-50 mix of doing failure analysis and process qualification. Now, that could be, like you said, send me, a dead body of a printed circuit board, that was perfectly fine before it went into the field, and we can kind of look at what's left of it, and then we want to investigate exactly how we got there from here. So, so we do a fair amount of that, along with all the standard process qualification, a lot of IPC qualifications with the new changes to Section 8 or J standard. We're seeing more and more customers that are paying more attention to their cleanliness, and as you mentioned, that really is a very important foundation when it comes to reliability. Reliability is not just one thing; it's becoming more of a master of many,
right,
to get to that 20, 30 year warranty.
Another thing that our companies have in common, and you and I have in common, is our view on the old cleanliness standard. The old cleanliness standard, which was used for 40 years,
Sure.
Probably close to 50 years. It was developed in the 70s. Used a resistivity of solvent extract test, a bulk tester, to test for ionic species of residues on the assembly. And there was a magic number. These machines express cleanliness in micrograms of sodium per square inch. So, but the magic number was 10. If you're at 10 or below, ship it. Parts are great. If you're at 10.01, parts are dirty. Don't ship it. Or 1.56 if you're in the metric world. We, for many years, said, that's bogus, guys. How can you do 10? How can I tell you 10 if I don't know what your stuff does?
Right.
And I know your company, Foresite, develop their own criteria.
Sure.
Not just bulk contamination, but 10 of what? Is it 10 of something that is, weak organic acid, that's something that may or may not be as problematic as another residue species? It really matters what the contamination is. And you guys did a really good job through your experience in calculating and publishing internal standards, not recognized by any body, but based on your years and years and years of test results and anecdotal experience, you were able to come up with your list of what numbers not to exceed based on specific residue species.
Right, and much like, we always said with the 1.56, the historical acceptance criteria, we have Foresite recommended limits for ion chromatography, allowable ions for expecting good performance in the field. Now, but we will tell all of our customers, loud and proud every time, these aren't hard numbers that say, if you are at 6.1 micrograms per square inch of chloride specifically, you're going to have a failure. There are so many things you have to take into consideration, the same way the IPC finally did with removing that number, end-use environment, voltage, spacing, metallization, there are so many different variables that
cost
impact
of failure,
a one-size-fits-all kind of number, that's just something that was really never applicable to the electronics industry as a whole, but even within the old standard, if it works for you, great. You've got, historical objective evidence that says we've used this for 30 years in our field service environment, this number has been, more than enough to be great. Keep using that number, Even the IPC is not saying don't use that number.
Right. In fact, they're saying just
verify.
the opposite.
Yeah.
If you've been using it and you haven't had a specific type of failure related to those numbers and you haven't made any changes in all this time, that's your objective evidence. Keep doing it.
Yeah, right. So you're right. All of the independent labs, we generally have similar numbers for allowable ionics, but there's not one independent lab out there saying this is it. Hard, fast failure, absolutely, if you're 1% above what we recommend for bromine, for example. So, it's really coming around. I think I knew it was going to be like pulling hen's teeth. I knew when they pulled, the one-size-fits-all number out, I think the whole industry kind of, stopped. The world was
Freaked
rocked
out.
because they had been doing something for so long where they could just check a box and it was great. But now, after a couple of years, so that was Rev H. Rev G that they removed that from. So we're on Rev H now, and all this past weekend we were working on the J Standard 001 task group. So, it's going to go to its third Rev of being out of that J Standard. And I think what that's done is that's forced so many customers to look inward and say, okay, what do our numbers need to be? Now we've always built to the IPC standards. Now Section 8 says create your own numbers for how you're going to do process monitoring beyond the initial qualification using surface insulation resistance. You add the ionic element, and that's good for your process monitoring tool. Now you determine 1.56, do I want to use ion chromatography? There are other methods out there, to do a process monitoring, but those numbers have to mean something, and now you have to back it up.
Right. I think what caused the industry to freak out is A, as you said, they took away a number they've been using for 40 years, and B, they didn't replace it with an alternate number. What do engineers want? Engineers, give me a number. I it may be a hard number to hit, but just tell me where I need to be and we'll figure out a way to get there. Right? Just, it's a goal.
And now you're drawing your own line in the sand.
And now the answer to, how clean is clean enough is, to paraphrase it accurately, is it depends.
Yeah.
You tell me and show me how you came up with that number based on objective evidence.
Right.
Provide me the evidence.
So going back to the original question, about Foresite, we're doing a lot more process qualification on new products now than we probably ever have in the industry since I've been there, because there are customers saying, okay, what do we have to do to meet this, specification that we can present the data to our customers? So, but that's really a good thing. The whole, the reason we're here, specifically companies like yours and mine, we're trying to improve reliability and performance for customers. That's bottom line. You're trying to clean them. I'm trying to prove that they're clean, and the whole idea is just to make more reliable product in the field. And I think now customers are really looking at that closer for their own individual process and not allowing an external source tell them, well, how clean they need to be when they really have no idea.
Right. You and I, Foresite, your company, produced a DOE, which we weren't involved in, but I loved that DOE. It was basically, you reflowed a bunch of test boards, dummy boards, with real materials and dummy components, but real simulated dummy components, and you intentionally, it was a no clean flux, and you intentionally ran various profiles slightly off, slightly lower, and then a little bit lower, and then a little bit lower.
All the way down till the parts fell off.
All the way down to the parts fell off, right. So take out where the parts fell off, because that would never make it out of the shop anyway. And then you subjected those boards to ion chromatography, which is a process for my viewers or listeners that aren't aware, will basically extract samples of the residues and run them through analysis to identify what it is, right?
Correct.
Fingerprint, basically.
Speciates the ions. Yep.
Exactly. So you can tell if it's flux or if it's wash chemical or if it's certain types of ions and whatever. And what you guys found was, with no clean flux, which was the intent would be not to clean it, as the reflow temperature or the peak reflow temperature dropped a very minor amount from a percentage standpoint, 1 or 2 or 3%, the number of detectable harmful ions or ionic residues on the board rose.
Correct.
Some rather dramatically. Some were like 300%, 400%, 500%, 600% in some cases, with just a few percent difference in reflow profile. We were so impressed by that study that we did another study where we, instead of basing the testing on ionic residue, on ion chromatography, we wanted to do SIR testing, surface insulation resistance testing, on boards that went through the proper reflow temperature and then 2% lower and 2% lower and 1 or 2% lower still, and then simply subject them to SIR testing. And we wanted to do it that way because the new IPC cleanliness testing standard says you gotta do SIR testing. So for 168 hours minimum. So it's okay, fine. We'll do the IPC tests. We'll reflow a bunch of boards. We'll run them all at various profiles. None of them which would affect solderability. They all look good. They all stayed on the part.
Right.
You would ship those otherwise. Couldn't see any difference.
Right.
But we just subjected them to SIR. And the boards that were reflowed at 5% lower, 5%, miserably failed SIR testing. It wasn't close. It's not like one line dipped in, below the red.
Right.
Half the thing was below the red. So that really, if I were an assembler, I would be incredibly alarmed by that. Because if you are running a no clean flux and you're choosing not to clean it, which is the preferred method, right? That's what it was intended for. Although it's the number one flux being cleaned today, ironically.
Which I have thoughts on.
The intention would be the intention would be to not clean it. You're going to set up a qualified process. You're going to make sure all your ducks are in a row. You're going to produce the best board you can. You're going to reflow it perfectly. Everything's going to be just like golden because you're going to pay a lot of attention to it. And then you're going to test it with SIR, and it's going to come out as a high pass, as it should. And then you're going to go, whew, okay, we got our process. Now push the production button. And what happens over time?
Yeah. Things drift.
Things drift.
Processes change.
Just even in a minor way. But if
Right.
you're relying on, I don't need to do any testing because we did the qualification and everything was fine by a high standard, I never need to test again. All of a sudden they're shipping product out the door that would have otherwise failed had they tested it, but they're not testing it because they already did their test, and they're just relying on kind of old data.
Right. They're not doing the process monitoring.
Right.
Right.
And that can come back to bite them. And I'm sure in your world, correct me if I'm wrong, but when you get a phone call or an email from a prospective client or an existing client that says, we have a problem, come out. How much of that is based on they thought they had a process that drifted and they didn't realize it drifted? Is that kind of the primary driver of the category of problems you have?
Yes, I would say that is one of the primary drivers where, we've always done it like this, we haven't changed anything, and all of a sudden we're getting failures, where we're testing things and they're failing miserably or they've got field returns, then we go on site and we find that their maintenance records haven't been, properly upheld, but more importantly, they're not doing the easy things like doing thermal profile on their reflow, that they're not checking the amount of spray flux, they see the program's the same, but they're not marrying that with what the equipment is actually doing. So, when we go on site and we look at equipment, we start from incoming to final packaging for raw materials all the way up to final packaging the assemblies, and we see, okay, where haven't you looked yet, And there may be places that they've looked, but they don't realize that they're not using the right tool to look. The going back to that first paper that Foresite did with the ion chromatography, looking at the lower temperature of reflow, that was based on some customers that had some high thermal mass parts. And, the end of that report, I said, hey, put 6 thermocouples on your board and let's see exactly what, what the profile looks like. And we were seeing 8 to 10 degrees difference in some spots on these really high thermal mass transformers or, parts like that. And then we saw the one-to-one with the ion chromatography data that says, okay, this saw less temperature. It still has the higher amounts of the no clean flux activators that should have been properly outgassed if it saw the right temperature. So there's so many customers that are using bare boards or non-fully populated boards to do thermal profiles for for SMT reflow, and we say, hey, this thermal loading is very important for all of your assemblies because this material per the manufacturer has to reach this temperature for X amount of time for it to become near benign as designed. And like you were saying earlier, even the ones that we knew would be failing SIR for the paper that we did together, they look the same as the ones that were properly processed. You can't inspect cleanliness. Right. You can inspect for visible residues, but you don't know if that's an active residue or not.
Right. You don't know if it's harmful or
right.
Or whatever. Yeah. It's. I always tell people the problem with inspection, visual inspection, is everything you see may not be harmful, and everything you don't see might not be there. It could be there.
Correct.
Right. So it's. One should look. I agree.
Sure.
One should look. In fact, one of the reasons in our reasons for cleaning, when we talk about the reasons people clean beyond the poster child reasons of electrochemical migration and all that, one of them is to make it look pretty. And what's the importance? Dull solder joints, for example, are not an IPC defect.
Right.
Right. And dirt is not necessarily an IPC defect. The results of that could be, but the presence of it is not. Cosmetic stuff is generally not considered a defect on its own. But what happens when a customer sees something that they don't expect to see? Then they look.
Right.
And when they look, they find. And I challenge the best board manufacturers, the best assemblers, if every board that you made was shipped to a customer and put under a 16X or whatever and inspected, they're going to find something that would otherwise be benign, but they're going to find something they find offensive, and they're going to reject it and send it back.
Sure.
You don't want to give customers a reason to inspect.
Correct.
How many times have you gone to a restaurant and your wine glass has a lipstick on it? Now all of a sudden you're looking at your spoon, you're looking at the bottom of your plate.
Right.
Now you're CSI, right?
Right.
Now you're
Yeah,
totally
exactly.
CSI.
Yeah.
And you just don't want to give people the motivation to.
Right.
You want them to open the box and assume everything is perfect the way
Correct.
they want it to be. If you give them any reason to suspect it's not, they will find something.
Yeah, and if you, like you said, if you look hard enough, you can find it. I mean, it could be completely benign, obviously, but there are some customers who will see that, and there are few worse reasons to clean than visual inspection.
Right.
I don't need a shiny, field return. That doesn't make it a better field return.
In fact, engineers
if
often
the solder
say,
joints are shiny.
never rework something to make it look better.
Right.
I mean,
Is it
every time
functional?
you expose it to some kind of rework process or heat excursion or whatever, you're now affecting reliability by a measurable amount. So it's like you never fix for cosmetics.
Right.
You just let it go. Or either if you're embarrassed, don't ship it. But
if it's that bad, sure.
if it's that bad. But otherwise, knowing that it's not harmful, it's just maybe a
Right.
little dent in your reputation, but it's not harmful.
Right.
Let it go. So I've said for years that cleaning is kind of a go big or go home process. And it's not often you hear me, well, let me back up a little bit. Maslow's theory was if all you have is a hammer, everything looks like a nail.
Right.
Well, if you're a cleaning guy, everything looks dirty.
Right.
I measure the whole world in terms of clean or dirty,
Sure.
right? And clean is always bad in my world, or dirty is always bad. It's always bad. Non-clean is bad. But the only time you'll hear me say don't clean is if the alternative is to not clean well, right? And you're better off just don't try it. It's
Absolutely.
go big, go home,
Yep.
right? Do it right or don't do it at all.
Correct.
You have an example of that. You and I were talking earlier off camera,
Sure.
and you were telling me about we'll keep the customer anonymous to protect
But not so
them,
innocent.
but not so to protect the guilty. But what they did actually, maybe not the specifics, but what they did is very common. Maybe not specifically that way, but
Right.
why don't you share with me again and my audience
Sure.
on that particular story?
So
I found it
was,
fascinating.
I was recently at a customer's, and we were working through some cleanliness issues, and we were using a localized test, a piece of test equipment, and we tested these samples before clean. They wanted to do before and after clean to see how effective their process was. Makes total sense. It's a great way to start collecting that objective evidence. Well, the dirty board, the as produced board was, it failed in 40 some seconds. So I said, well, let's bring me totally expected, with no clean flux, you can have some dirty residues left over and that's fine. If it doesn't see the right temperature, we were just looking at, baseline cleanliness. So they brought me some cleaned boards and it failed in 11 seconds. So they were actually making these boards dirtier. So I said, okay, let me go look at your wash system. We've got some experience with different types of wash systems. So the engineer I was working with walks me over to 2 batch cleaners, highest quality ones on the market. I'll tell you that right now. So I'm looking at settings, and all of a sudden I see behind the 2 batch washers there is a table set up with 2 operators using ESD brushes and sharing an IPA bottle top dispenser, and they're dabbing, they're scrubbing the boards, and their rinse process was to hand them to a 3rd operator who was using shop air just to blow them off. So
they got oil on the board.
This
at
started,
least,
this started one heck of a conversation on our front with me and with the engineers I was working with and myself. And I let them know, look, improperly cleaning a no clean flux is just as bad, or can be worse than leaving small pockets of water soluble behind. That no clean flux, everything's supposed to be bound within that outer
Right.
resin shell,
All encapsulated.
Poor man's conformal coat to some people.
Right.
So you have to make sure that if you're going to clean no clean flux, you have to solubilize everything and then do an effective job of rinsing. They weren't rinsing at all. They were blowing the big chunks off with this shop air, and it was, if it wasn't so sad, it'd be, comical. I'm like, I don't understand who in this company thought this was a good idea. What I was told was they're high mix, low volume. So they would have to have waited so long in between, manufacturing the board and them going to wash. They thought that it made more sense to clean, sooner, even though it was this subpar cleaning process compared to an automated system.
Right.
Well, they've since learned that that's not going to be the process going forward, because they had no idea that they were actually making these boards dirtier than what they were before they started. So, customers don't always know what they're doing or have the right reason. Cleaning, no clean, we've discussed I still believe that it is a decision made from a C-level suite somewhere of somebody who says, oh, it's no clean, so if we don't remove it all, it's no big deal.
And no clean means don't clean, right? I can't tell you how many customers I've talked to in the 37 years I've been doing this that think that if they're cleaning a no clean, they're doing something wrong. It's an admission of guilt. They're almost embarrassed. It's like, you're not supposed to clean it, but we can't figure out, boards keep failing, so we have to do. So, we're obviously doing something wrong, but we're not smart enough. So they're ashamed to admit they clean.
Right.
And a flux manufacturer came to me after I was giving a lecture, and usually they come up, they stand in line to talk to me, and then they bitch and moan about me, like I'm calling their stuff no good.
Right.
And I'm not at all. No clean residue is as close to benign as you can get. The problem is if you don't clean it, you don't clean anything. It's a totality. So I make that clear. And I've been forgiven by most of them. But one guy came up to me and he said, the reason we call it no clean is no clean doesn't mean don't clean. It means it's the species of flux you would choose if you are not going to clean it. You wouldn't choose an organic acid. You wouldn't choose an RMA. You'd choose no clean. It's just, this is what you use if you're not going to clean it. If you are going to clean it, you can still choose it, but it doesn't mean it's intended to not be cleaned.
Right.
The flux companies years ago realized people are cleaning their stuff. So, they used to say it's not intended to be clean because it was hard to clean.
Right.
And they would say, don't try and clean it because we don't want the service calls, right, if it's not coming off.
Right.
But I think there's a huge acknowledgement that I think from my vantage point, most, that may not be totally accurate, but from my vantage point, most no cleans are removed.
I would say the vast majority.
We do polls, and our polls indicate about 53%. But I'm sure, and that's North America. Overseas, different story. Overseas, they have iPhones. I don't think very many parts of the iPhone are cleaned, but they have this economy of scale that us mere mortals don't enjoy. They have this ability to design to not clean. You heard about design for manufacturability. They have design for non-cleanability. They can design out things, and they can design their boards so that you get better outgassing under QFNs and things. They could do all this stuff that we wouldn't do.
Right.
So, but in the whole world, real quick, we only have 2 minutes left. That went fast.
That went really fast.
Tell me about localized testing. You talked about localized extraction testing to evaluate cleanliness. Just give me a 2-minute version of what that's actually doing.
Well, many know I work for Foresite. We have the C3 tester.
Yeah.
But it really came out of a need to serve our customers better, because we were getting big expensive server backplanes and doing mechanical removal around the part that was failing. So as much as I believe in the C3, I think one of the important things, and it has been pushed more and more here at the IPC, the technical meetings, is the process of localized extractions being more valuable to a failure analysis, and even a process qualification than a full board extraction. That was one of the problems with the 2325, the Rose test, or the 2328 ion chromatography test. The basis was, you're trying to determine how much material you can remove, and then it averages out across the full surface area of the board. Well, if you've got one part that's really hard to clean, like a QFN. QFNs are the magic component because you can't wash them, you can't process them with no clean. There's not enough standoff height to get solution underneath, and there's that's not tall enough to let everything out gas. So being able to determine how well you can clean the hardest to process parts, be it thermally or if you're doing a wash, you have to use a localized extraction process to determine how clean that is. And through some common sense, you can say, okay, if I'm cleaning these, if these are good, everything else on my board should be good. So, it's one of the things that I think we've been pushing, through the IPC for a while. And it's not just, Foresite. There are a lot of other companies working on the ion chromatography task group.
Yeah. I like it. I think it's a great compliment to, if I look at it as like a police work, if someone robs a bank, they set up a perimeter and they start really canvassing the area within that perimeter.
Right, exactly.
It doesn't make sense to go to another state and start canvassing.
Absolutely,
right?
yeah.
And bulk Rose testers, they serve their purpose. You can't do it all with local. You can't do it all with bulk. Bulk searches the entire board. It doesn't tell you what it is or where it is.
Right.
It just says, something's higher.
It's the perfect tool for process monitoring.
Absolutely.
As it was manufactured to be.
But if you got to find out where it is, exactly.
Right.
Back when people were listening to David Bowie on their 8-track tape, Diamond Dogs going to work. And with David Bowie, we'll let that be our segue, hard segue out. Eric, thank you so much for being my guest today. You're always a thrill to talk to. We have these same conversations in bars. I have to say, it's just without the cigars and the drinks, but we just talk about cleaning. We're cleaning nerds. So thank you to my audience. We don't talk about cleaning very often on this show, but when I get a chance to, I always love it. Be sure and subscribe to the podcast so you don't miss an episode. We release new episodes on the second and fourth Tuesday of each month. If you're listening to this on Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, wherever, be sure and subscribe and like. And if you're watching this on our YouTube channel, or if you want to watch this on our YouTube channel, what? We have a YouTube channel? Yes, we do. Be sure and click the subscribe button and the bell icon so you can be notified when new episodes are released. Thanks again for watching. If you're watching this live, thanks for being there. If you're watching this sometime in March on my regular channels, I'll see you again in 2 weeks. So again, thanks, Eric.
Absolutely.
Bye for now.